Good morning, all. In today's class, we are going to discuss about the concept algorithm. Algorithm is very easy, but at the same time, it acts as a stepping stone to all other programming languages. Why? Because we know we are creating programming in order to train the computer system. Correct. So we have to train the system properly. Then only we'll be getting the desired results. We are having different set of problems and we have to find the solutions. So in order to find a solution, there should be set of procedure or step by step procedure to solve that particular problem. The step by step procedure to solve a particular problem is known as algorithm. Okay, so algorithm is a process or a set of rules required to do perform calculations or some other problem solving operation, especially by a computer. And the formal definition of an algorithm is that it contains the finite set of instructions which are being carried in a specific order to perform specific tasks. It's not the complete program of code, it's just a solution of a problem, which can be represented either as an informal description using a flowchart or pseudocode. So basically, algorithm is step-by-step procedure to solve a particular problem. Depending upon the nature of the problem, the steps and the sequence should vary. Correct. So there is no proper structure or rigid structure for writing algorithm. There is no defined rules like this algorithm should be like this. But there are some rules to be followed when we are writing an algorithm. And there are some characteristics for algorithm. That is, there should be input, output, unambiguity, finiteness, effectiveness, and language independent. So basically, algorithm means it's a step-by-step procedure to solve some particular problem. To solve a particular problem, we need some input, correct? We are getting the inputs, and after that, we'll be solving that issue and we'll be getting some output. One or more output will be at the ending of an algorithm. And this algorithm should be unambiguous, which means the instruction should be clear and simple. It should not make any confusion. That is, we have to solve a problem, so the instruction for solving that particular problem should be clear and simple. And the most important one, the finiteness. That is, the algorithm should end in a finite number of steps. That is, the steps to solve a particular problem should be finite in number. It should not go in infinite times. There should be a limit for solving a particular problem. Then only its time will be reducing. We'll be getting the output easily. Correct. And one more thing, the effectiveness. Each and every instruction should have an effective role in this problem solving procedure, that is in this step by step procedure. And one more thing is that it's language independent. An algorithm must be language independent so that the instruction in an algorithm can be implemented in any of the language with the same output. So the characteristics are its input should be there, output should be there, unambiguity, the instruction should be clear and simple, and there should be finite number of instructions only, and each instruction should be effective, and it should be language independent. Then the next one is data flow and algorithm. How we can finally reach to a solution. First one, in order to create an algorithm, we should have a problem. If we are having a problem, then we have to find the solution. So first one is problem. A problem can be a real world problem in or any instance from the real world problem for which we need to create a program or the set of instruction. The set of instruction is known as algorithm. Okay, some problem is there, we have to find a solution. For that, we have to generate the algorithm. It's a step by step procedure and it should be have an input and there should be a processing unit. That is, the input will be given to the processing unit and the processing unit will produce the desired output. The output is the outcome of the result of a program. That is, the problem is solved. It's entered. Finally, we are getting this output. And why do we need algorithms? That is, scalability and performance are the major reason for the algorithms. Okay, why we need algorithm? Why? Because the scalability and performance. That is, if you are having a very big problem or a large complex program, we have to scale it down into small steps. Okay, if we are solving in one single struct, it should be very complex. We can't identify how to solve. So we have to easily break down. We have to break down, then we can easily solve that. And at the same time, the performance will be also increasing. That is, we have just broken into smaller steps. That is, the problem is feasible in one or another way. So that's why we need algorithms. And how we can write an algorithms. As we told just before, there is no rigid structure or proper format for writing an algorithm. No well-defined standards are there. But there are some standards, widely accepted rules and regulations are there. Then algorithms are never written to support a particular programming code. As we know that all the programming language share basic code constructs like loops, flow control, this common construct can be used to write an algorithm. That is, we are having repetitions. Then in algorithm, we can use the same codes, correct, like do, while. And if we are having some decision making, we can go for if or check statements. Okay. So then algorithm is a step-by-step manner, but it's not always the case. Mostly the algorithm will be in the step-by-step procedure. An algorithm writing is a process and is executed after the problem domain is well defined. So how we can write an algorithm? So writing an algorithm, the first step should always start and the last step should always stop. Okay. So beginning with the start and ending with the stop. And if statements can be used to check the conditions. Okay. If there are some conditions, if there are some decision to be made, then we can go for if statement. To repeat steps different times, we can use looping keywords such as for or while we can be used. Okay. And the next one is how some examples for how to write an algorithm. Okay. So these are some examples for writing an algorithm. So as we told, the first step is start and the last step is stop. Okay. So here we are reading some variables. In order to read some values, generally we'll be using read statement. Okay. And in order to assign some values, we can either use equal to or we can use a reversed arrow. Like this also we can use. And here what we are doing, we are just reading some values. That is, we are just declaring and initializing happening here. And that is as some operation, addition operation is performed and that result is stored into the variable result. Okay, that result is stored in this particular variable result. And after that, we are just displaying. In order to print an answer, if it is C programming language, we'll be using printf. If it is Java, we'll be using system.out.println like that. So in order to display an answer, we can use the keyword display. Okay, for in generally declaring an initialization, we can go for read. And if you want to display the result, we can go for display keyword. Okay. And the ending with the stop. That is, this algorithm has entered in a finite number of steps. 5 steps are there. Start with the start statement, end with the stop statement. This is one way, and this is the another way. That is method 2. Here we are just reading the value and assigning it at the same time. So always start with the step 1 start and end with the stop. Okay. So here we are just reading 10 to A, 20 to B, and we are calculating the sum and assigning the result, obtained result into the variable result. And after that, we are displaying the result. Okay, so for displaying the result, instead of printf, we can go for display. If you want to read something, then we can go for read. And if you want to assign something, we can go for either reversed arrow or normal assignment statement can also be used. Okay, and one more method is that is this one. Here, as usual, starts with the step start and it is ending with the stop. Okay, so here we are just declaring variables num1, num2 and sum. Okay, that is just declared and after that we are reading values to num1 and num2. We are not specifying the values here. So it means we are reading the value during the runtime. Okay. During the runtime, we are just reading the values. And after that, we are performing addition operation and the obtained result is stored in the variable sum. Okay. Here we are using the reversed arrow in order to store the result into this particular variable. After that, we are displaying the value that is in the sum. Okay, display sum, then it is end with stop statement. These are the some generally accepted format for writing algorithms. So as we told, we don't have a rigid structure or standard rules for creating this algorithm, but some guidelines are there. That is start should be the, stop should be the, and each and every instruction should be precise and it should have an effective role and there should be finite number of steps. Okay, so these are the main idea about the algorithm. Okay, thank you.